Assalamu alaikum. This is Javed Hossain, student of Master of Port and Shipping Management, batch number 8, ID number 23212012. So here I will try to give a presentation on effective ship emission reduction techniques using current technology. And let's start. Content. So in my presentation I will try to cover up these contents. Number 1, introduction; 2, literature review; 3, methodology; 4, ship emission reduction techniques; 5, emission reduction based on fuel savings; 6, reducing emission from ship by using alternative fuel; 7, selection of appropriate emission reduction method; 8, applying emission reduction techniques; 9, SWOT analysis; 10, the conclusion remarks. Introduction. So first I would like to start with the impact of maritime shipping industry. As we all know that maritime shipping industry supports 90% of global trade, and it consumes 300 million tons of fossil fuel annually. Also 35.64 metric tons of carbon dioxide, that is 2.2% of global carbon dioxide emissions. This is according to the International Maritime Organization. Now we will see the IMO strategy. IMO aims for a 40% reduction in carbon intensity by 2030 and 70% by 2050. So it focuses on zero emission fuel like e-ammonia, e-methanol, green hydrogen, etc. Now we will see the challenges. The technological advancement and infrastructure development is the biggest challenge right now. So the things I would like to present here, that we know that ship has a long life around 20 to 25 years. So also at present in the market, we will see that most of the ship are run on the heavy fuel oil, that is a fossil fuel oil. So it is impossible to just make a quick transition from fossil fuel to this green energy. And so the problem here, we will face the technological advancement and infrastructure development, of course. So my research objective is to explore the strategies for reducing ship emission through existing technologies, as to change in the alternative fuel is a long term goal. So I would like to focus on the existing technologies to reduce emission, and a SWOT analysis to assess practical and feasible approaches for emission reduction. A literature review. There are many papers published on the heavy fuel oil emission impacts. I'm not going to explain them all, and I will try to explore the several proposed measures and versus my findings. So while measures like the EEDI, EEXI, and CII aim to improve ship energy efficiency and reduce carbon oxide emissions, many emission reduction technologies, including fuel optimization, exhaust after-treatment system, seawater scrubber system, shore connection, and alternative fuels, have the potential to lower emission. Even if several measures have been proposed, the greatest number of them were agreed upon to move to alternative fuel, but achieving this will take time. Additionally, putting some of the new procedure into practice is quite challenging and very costly. Therefore, in my investigation, I focused on determining the best emission reduction techniques utilizing onboard management and current technologies, as many of the proposed measures have yet to be widely implemented. Additionally, I will explore the potential of alternative fuel and renewable energy sources such as natural gas, hydrogen, wind, and etc. Methodology. The selection of studies was based on a qualitative assessment of the relevance of the study for estimating ship emission reduction based on current available technology. I basically used a systematic assessment of all prior studies of ship emission reduction measures, and this paper especially focused on the main ship emission pollutants such as nitrogen oxide, sulfur oxide, and carbon oxide reducing method using existing technology. While many researchers published their result to shift alternative fuel to reduce ship emission, but I focused the best effective technology for reducing ship emission, considering the practical scenario and challenges. And also I conducted a SWOT analysis of the best chosen technology, ship emission reduction techniques. So nitrogen oxide emission reduction technology, and there are various technology, but selective catalytic reduction, in short HCR method, is the best option for nitrogen oxide emission reduction. And SOx emission reduction technology, the best technology is wet desulfurization technology and hybrid desulfurization technology. Later we will discuss it. And carbon dioxide emission reduction technology, there are several method has been revealed and published, but among them the most common ship energy efficiency design index and ship energy efficiency operational index is most operational. The available method for reducing ship emission, NOx, SOx, and carbon oxides. The reduction method, we can see there are various reduction methods, but at the top, the selective catalytic reduction, in short HCR, can reduce the nitrogen oxide emission up to 95%. And for the SOx reduction, the seawater scrubbing and exhaust below waterline can reduce sulfur oxide up to 95%. And for carbon oxide reduction, the energy management can reduce carbon emission around 1 to 10%. The ship emission reduction based on fuel savings, there are also various methods of reducing the emission. Number one, lowering ship resistance. So if we can lower the ship resistance, the fuel consumption will be reduced, and as a result the emission will also be reduced. And renewable energy, and if we can use the renewable energy, the emission reduction also will be reduced. Number three, improvement of energy performance. So we can just reduce the emission simply improving the energy performance of the ship. So the fuel we use for engine, and if we can use the best output, we can use the best output of the power of engine, so no waste of the power. So it could be a possible way for emission reduction. Like, if I give an example, suppose if ship we have various machineries and we have to run many machineries, that is, so if some machineries we do not need to use, we can simply put in and turn off, and so that can also reduce the energy and also reduce the finally reduce the emission reduction. And number four, reduce ship speed. There are some researches that have published that by reducing ship speed, a significant amount of emission can be reduced because reduced ship speed can reduce the fuel consumption, which can also reduce the emission. Shore power connection. It is a very popular that if the ship is now on at shore, I mean at the port or terminal, so that time we can just use the shore power instead of the ship power. So it will helpful for emission reduction also. Now we will see the reducing ship emission from ship by using alternative fuel. So the hydrogen and natural gas is most famous alternative fuel at present, but the hydrogen is not very much available. So it is still on the process, but natural gas is still we can see some of the vessel already they have changed their fuel to fossil fuel to natural gas. Applying emission reduction technology. Here is a full diagram of the process of how we can reduce the ship emission. So number one, we can see it is our engine, and number two, exhaust gas, urea stress tanks for the nitrogen oxide reduction. Number four, delivery urea pump for the injection of the urea using this pump. And number five, control flow rate unit, injection urea converter, nitrogen oxide analyzer, emission measurement, funnel casing. So here is just a complete diagram of how we can actually use the selective catalytic reduction with the CO2 scrubber, so that this system can significantly reduce NOx and SOx and also carbon dioxide emission. Let us now discuss about the most important part of my presentation, that is strength, weakness, opportunity, threat, in short SWOT analysis. So what are the strengths of seawater scrubber system? So what are the strengths of selective catalytic reduction and seawater scrubber system? So number one is comprehensive emission control. So previously we have seen that this system can reduce NOx oxide up to 89% and SOx emission up to 95%. And it has operational flexibility and improved fuel efficiency, also integration capabilities. This system can use with another technology. And finally, the modular design means it has a very compact size, so that the system is really a space savings, that is really important. And what are the weakness? So the first weakness is it has a very high installation cost, and so to install it take a very huge investment. And secondly, chemical handling risk, dependence on water quality. It means the output of the system varies on the water qualities, as ships sail in different areas and water is different, so the output may be vary sometimes. Maintenance and downtimes and regulatory limitations. Opportunities. So the opportunity here we see regulatory compliance, so that the system meets the IMO regulation requirements, and it has a very environmental benefits and technological advancement and good adaptability. Now we will see the threats. Number one is the regulatory change. So this is a big threat, because as the day goes on, we see there is a very changes in the regulatory. So in future, this system may not be maybe prohibited. So this could be a threat. An environmental concern, maintenance cost, skilled manpower to operate, and supplies in scarcity. Supplies in scarcity means to run the system we need some special chemical like sodium hydroxide. So as the ships sail in different part of the world, in some area these chemicals may not be available. So this is a big threat to run the system. Finally, the conclusion, and the study focuses actually the reducing the emission from ships, particularly SOx, NOx, and carbon oxides, through the method like selective catalytic reduction and scrubber system. It also highlighted LNG and hydrogen power fuel as a alternative fuel, and despite the benefits, global implementation of alternative fuel face challenges. The study offers practical strategies for effective reducing key ship pollutants, emphasizing the need for tailored solution in the maritime industry. So it is all about my presentation. I'm finished here. Thanks for watching. Assalamu alaikum.